Hello friends, today we'll discuss some theorems of divisibility. This lecture number 3rd. So theorem A divides B divides A, then A is equals to plus or minus B. Therefore, proof A divides B by the definition of divisibility. B is equals to AX1. X1 belongs to Z, equation number 1, and B divides A by the definition of divisibility. A is equals to B x2, and x2 belongs to any integer, equation number 2. Put equation 1 put equation 1 in equation 2, we get A is equals to A into x1 into x2. Therefore x1 comma x2 belongs to Z. Therefore A get cancelled. Therefore 1 is equals to x1 into x2. That implies x1 into x2 is equals to 1. Therefore x1 is equals to 1, x2 is equals to 1. Therefore there is for x1 is equals to minus 1 and x2 is equals to minus 1. Therefore above values, these 4 values, substitute in this equation, we get 1 is equals to 1 into minus 1 into minus 1. Therefore equation 1 becomes, therefore equation 1 becomes B is equals to AX. Therefore B is equals to A or B is equals to minus A. Therefore B is equals to plus or minus A. Therefore from equation 2, therefore from equation 2, A is equals to B, A is equals to minus B. Therefore A is equals to plus or minus B. Therefore from equation 2, A is equals to B, A is equals to minus B. Therefore A is equal to plus or minus B. Hence proof. Now next theorem, A divides B, A greater than 0, B greater than 0, then A less equal B, then A less equal B. Here is the proof. We have given A divides B by the definition of divisibility. B is equals to Ax. Therefore x belongs to Z, any integer, equation number 1. And we have given A greater than 0, B greater than 0, and we have to prove A less equal B. Therefore we have A greater than 0, B greater than 0. Therefore we can say A not equals to 0, B not equals to 0, and x not equals to 0. Therefore x greater or equal 1. Multiply both sides by A. Therefore Ax greater or equal A, but B is equals to Ax. But B is equals to x we have to given. Therefore substitute value of Ax is equals to B. Therefore B greater or equal A. That is A less equal B. Hence we can prove our theorem. Okay. Now we will move to next theorem. Given that given if m not equals to 0, a divides b, then ma divides mb, ma divides mb. Therefore proof we have to given m not equals to 0, a divides b, but by definition of divisibility, b is equals to ax, x belongs to z, equation number 1, and we have to prove ma divides mb. Therefore multiply equation 1 by m, multiply equation 1 by m. Therefore mb is equals to max. Okay, therefore we can say that by definition of divisibility, ma divides mb. In that theorem we have to prove both way, if and only if. Here we can write if and only if. Therefore we can prove converse part. Okay, that means ma divides mb, then we have to prove m is not equals to 0 and a divides b. Therefore conversely assume that ma divides mb. Therefore by definition of divisibility we can write mb is equals to max, and x belongs to any integer z. Therefore in that get cancelled. Therefore we can write b is equals to ax. Therefore we can write by definition of divisibility a divides b. Therefore here we can prove if and only if part. We first consider m not equals to 0, a divides b, and prove a divides mb. And converse part we can assume ma divides mb, we have to prove a divides b. Okay, now we will discuss next theorem, division algorithm. Statement of division algorithm. Any integer a and b with a greater than 0, there exist unique integer q and r such that b is equals to aq plus r, where 0 less equal r less than a, 0 less equal r less than a. If a into b, then r satisfies the inequality, 0 less than r less than a. Here we have to show division algorithm. The statement of division algorithm is a and b, any integer, but here with a greater than 0, that means a not equals to 0. Okay, a not equals to 0. With there exists a unique integer, this one q and r, such that b is equals to aq plus r, and this r satisfies 0 less than r less than a. That means here r value of r is not 0 and a. Now we discuss the proof. What is the proof? Let a and b, let a b belongs to z with a greater than 0. We prove this theorem in two steps. This theorem we can prove two steps. Step first, existence of q and r. Existence of this q and r. Step first, existence of q and r. Therefore, consider the set S is equals to b minus ax such that b minus ax greater equal 0, x belongs to z. आपण असा एक सेट कन्सिडर केला आहे बी मायनस ए एक्स. तो कसा आहे? बी मायनस ए एक्स हा पूर्ण सेट ग्रेटर इक्वल 0 म्हणजे 0 आणि 0च्या पुढच्या व्हॅल्यूज घेतलेल्या आहेत. देअरफॉर फॉर ए ग्रेटर इक्वल 0, दॅट इज a greater equal 1, a greater equal 0, that is a greater equal 1. Here we multiply this a greater than equal, multiply both sides by mod b, multiply both sides by mod b. Therefore, mod b into a greater equal 1 into mod b. Now add both sides b. Therefore, b plus mod b into a greater equal b plus mod b, b plus mod b. Therefore, b plus mod b into a greater equal b plus mod b greater equal 0. Okay, greater equal 0. Therefore this equation we can write like this: b minus mod b into a greater equal b plus mod b greater equal 0. Therefore, for x is equals to minus of mod b, b minus ax belongs to s. We have to set of s. Therefore, b minus ax belong to set s, and s not equals to phi म्हणजे which is non-empty. Okay, therefore next, that is s is non-empty subset. Now by using well ordering principle, s has list element, say r. Therefore, r is equals to b minus aq, q belongs to z, and r greater equal 0. Therefore, this equation we can write b is equals to aq plus r greater equal 0. Now we have to show that now we have to show that r less than a. Therefore we prove this by contradiction. To prove this contrary. Therefore assume that r greater equal a. That means r minus a greater equal 0. What is the value of r? B minus aq. Therefore b minus aq minus a greater equal 0. Therefore b minus a into q plus 1, a common घेतला, greater equal 0. b minus a into q plus 1 greater equal 0, and this one belong to S. Why this one belongs to S? We have to know the set of S. What is the set of S? B minus ax. Therefore we can use this b minus a into q plus 1 belong to set S. But b minus a into q plus 1 is equals to b minus aq into minus a, which is equals to r minus a less than r minus a. The value of this r minus a, and this one is less than r. This one is less than r, as r minus a belongs to S and r minus a less than r, which is contradiction to our assumption. What is our assumption? R greater than or equal, and we have to prove r less than a. Therefore which is contradiction to the fact that r is the least element of set S. Our assumption is wrong. Therefore our assumption is wrong. Therefore r less than a. Therefore there exist q and r such that b is equals to aq plus r, 0 less than r less than a. Now step second of our proof. What is our step second? First we prove step first. We have to prove existence of q and r. Now we have to prove by our theorem their uniqueness. First we have to prove existence. Now we prove uniqueness of q and r. Uniqueness of q and r. Suppose there exist q and r such that b is equals to aq plus r, and this one 0 less than r less than a, 0 less than r less than a. Therefore also there exist q dash and r dash such such that B is equals to AQ dash plus R dash. Therefore 0 less than R dash less than A. Therefore what is the value of B? AQ plus R is equals to AQ dash plus R dash. And same here, 0 less than R less than A and 0 less equal R dash less than A. Therefore we have to take R minus R dash is equals to AQ dash minus AQ. Therefore in this A common, therefore Q dash minus Q, R minus R dash. Therefore 0 less than R less than A and 0 less than R dash less than A, equation number star. Equation number star. Therefore by the definition of divisibility we can this write A divides R minus R dash. A divides R minus R dash. Therefore 0 less than R minus R dash less than A. Therefore R minus R dash is equals to 0. Therefore R is equals to R dash. Therefore this value substitute in equation star. Therefore equation star becomes 0 is equals to A into Q dash minus Q. Therefore A Q dash minus AQ is equals to 0. Therefore AQ dash is equals to AQ. Therefore AA get cancelled. Therefore Q dash is equals to Q. Therefore thus R is equals to R dash and Q dash is equals to Q. This proves the uniqueness of R. This proves the uniqueness of R. Hence the proof. Hence proved.